Okay, so now we're going to go to numbers with decimals. And we're going to look at two of them, the float and the double. And the double, as we can expect, has a wider range than the regular float. If you look at how much memory they occupy, the float takes 4 bytes and the double 8 bytes. But look at the ranges. The float with 4 bytes goes from -3 to 10 to the power 38 to +3 to 10 to the power 38. And if you want to know how much 10 to the power 38 really is, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 22, 3, 4, 5, 6, 7, 8, 9, 30, 2, 3, 4, 5, 6, 7, 8. So this is 10 to the power 38, and if it's 3.4, you would have this much. So that's quite some range already. And then if we have to do the same thing for 10 to the power 308, it's basically a 10 with 308 zeros. Okay, so you can clearly see that this is a very large range with only 4 bytes over here. It also probably means that it's not as precise as it could be, because it has such a large range but only uses 4 bytes. That's why a double is actually better. If you multiply these numbers over here, 3 to 10 to the power 38, you would get about 9 times 10 to the power 1500 or so. And you see that that's definitely not the case. So part of these 8 bytes are going to be used to increase the range, but the other part is going to be used to make it much more precise. Traditionally we use floats, but it may actually be a good use to use doubles in your programs too. Now let's go to the first part over here, and this is about the E notation. And you see that distance over here is a float 1.496 E8, which basically means that this is 1.496 times 10 to the power 8. If we convert this number over here to the E notation, just think for a moment what that would be. Okay, so on here is the answer, 3.4 3.4 E38. And if we do the same thing for this one over here, 1.7 E308. Okay, so that's the first thing about that exponential notation over here. Basically means times 10 to the power and then whatever number follows. Let's go back over here and accept this, because this is actually a good thing. Now let's look at this over here. This falls well within the range of this one over here. This is only E8, this is E38. So if I run this over here, you see that I have 1.496 E plus 08 kilometers, and that's exactly the same thing, and this number is the same too. Let's go out of range again, and I'm just going to take something larger than 38. I'm just going to make this 48, and we're going to see what happens there. And you see that it will not accept that number. If I do something out of range over here. This is E308, and I'm just going to make this 400. And again, it's just listed as infinity because these are not valid numbers, and that's how this particular compiler handles this. So again, try to know these numbers over here. This is 10 to the power 38, and over here 10 to the power 308. Once you have those numbers, then you have an idea of where the range should be.